Okay, everybody. So we've been talking about parametric equations for, I don't know, the past one or two videos. I can't remember exactly, but I have at least one other video leading up to this point. And in the other videos, we just took parametric equations and we said that every set of parametric equations has a path. The path is a graph on the xy plane, and we just analyzed that sort of thing a little bit. All right, so we didn't do any calculus. And so what's calculus? Calculus is derivatives and integrals, basically. I mean, I guess calculus is a little bit more complicated than that, but when I say that we're going to have calculus and parametric equations, then we'll think a little bit about what the derivative concept would be in this situation. All right. So let's say that we've got x is g of t and y is h of t. Those are parametric equations. They give x and y in terms of some third thing, which I'm saying is t in this case. The analogy I gave you in another video was you could think of this being the motion of an object in 2 dimensions, where at every time that determines a position with an x coordinate and a y coordinate. So there's 3 things. There's time, and then position, but position is x and y. So that's a rough analogy of what parametric equations are. So you could think of that like, say, x is found by 3 times cosine 2t, and y is 3 times sine 2t. That's an example. All right, so say you've got that. All right, dy over dx, that's the slope of the tangent line to the path or curve that those parametric equations determine. Okay, like these parametric equations have a path that's circular, and at any point there's a tangent line. All right, okay, so this will tell you the slope of the curve or the slope of the tangent line to the curve. All right, so let's do this first example. It says give the equation of the tangent line to the curve that is at the point where t is equal to pi over 8. Now, let's just say for now, I'll explain this in a minute, but let's say for right now, the path, the curve on the xy plane determined by these is a circle that has a radius of 3 and a center at the origin, which I've sketched for you right here. Additionally, if you're interested in the point where t is pi over 8, if I just put pi over 8 for t and calculate x and y, I'll get that point. And what I find that point to be is if I take 2 times pi over 8, that's pi over 4. Cosine and sine of pi over 4 is 1 over root 2. So I'll get 3 over root 2 for the x coordinate and 3 over root 2 for the y coordinate. So that's the point on this thing when t is pi over 8. 3 over root 2 for x, 3 over root 2 for y. Okay, so I've got the path or curve determined by those. I've got the point that was given. And then in red right there, that would be the tangent line to this curve at that point. And that's the kind of thing that's what we're looking for. What's the equation of that? It appears to be a line that has a negative slope hitting the y-axis at some, like this would be 3 right there. This has radius 3. So it hits the y-axis at a little above 3 and hits the x-axis a little bit to the right of 3. Something like that, okay? So, all right, we'll figure that out. That's our goal right now. So let's break this down into steps. We'll say, so 1, what is the slope of the tangent line? Okay? You know, that thing right there, what's the slope of that? Well, that's what this formula gives me. The slope of the tangent line, h prime t over g prime t, or y prime over x prime, okay? So the slope of the tangent line, now I'm going to just call that m, because that's the letter we usually designate for the slope of a line. So m is going to be the derivative of 3 sine 2t. So that's going to be 6 cosine 2t over the derivative of 3 cosine 2t. So that's going to be negative 6 sine 2t by the chain rule. All right, derivative of sine is cosine. I get the 2 and the 3, that's 6. Derivative of cosine is minus sine. Again, with the 2 and the 3, I get 6. So that's my slope, and I have to do a little math from here. This slope depends on the t. It depends on the point. It's different at different points, all right? So I need to figure this out at t is equal to pi over 8. And if I do that, that would be cosine of pi over 4, which that's going to be 1 over root 2. I'll get 6 over root 2. And then down here, sine of, if I put pi over 8 in, that's going to be pi over 4. Sine of pi over 4 is 1 over root 2, so I'll get negative 6 over root 2. Okay, so while I did all that math, it turned out to be negative 1. All right, so now I have what would be a partial answer. I don't have a full answer to this one. I know that the equation of a line is y equals mx plus b in general, unless it was a vertical line. This applies to anything but a vertical line. And I figured out that the line I'm looking for has a slope of negative 1. So I get like this. And that leaves b, okay? So out of my partial answer, I just need a way to find out what b is. But I do know that this line, having that equation, passes through this point where x is 3 over root 2 and y is also 3 over root 2. So it's like I'd say, okay, well, it's 3 over root 2 for x, 3 over root 2 for y. That would be a valid point on that line, so I could put it in for x and y, and it should satisfy the equation. And that would be enough information to find b. So I get 6 over root 2 for b. Okay, that does reduce, let's say it'd be like 6 root 2 over 2, right? If I rationalize it, I'll multiply top and bottom by root 2. So let's say 3 root 2. Okay, so my answer, see that line in red right there? Its equation is y is equal to negative x plus 3 root 2. That's what we were after. What's the equation, that line in red right there? Tangent line. Okay, well, so we got that. Now, when I was doing this, I had my setup that, as a matter of fact, the path or the curve determined by those is a circle, radius 3, center at the origin. I didn't say how I knew that. I have talked about how you figure that out in other videos, but I haven't in this one, so let's discuss that. Why does this have a path that's a circle, radius 3, center at the origin? Well, how do you find the path, just in general? Okay, what do we mean by path? The path is an equation in x and y. If this is motion, the path is the path you take as you move. The path you take doesn't give information about time. It just gives the information about the place, the path, all right? So in other words, it has x and y, but not t in it. So generally, we find the path by eliminating t, okay? So if I can somehow get rid of t out of those and just have something with x and y, then I would have my path, okay? All right, now as far as this one goes, there's a hint about how we do that, all right? The fact that this involves sine and cosine is a clue that I'm going to use a certain identity to eliminate t out of it. So yes, we will use the fact that sine squared of an angle theta, it doesn't matter what the theta is, but sine squared of some number or angle theta plus cosine squared of that same number or angle is going to be 1 all the time. So we're going to use that, all right? Now, in order to use this somehow, I should probably solve these for sine and cosine. So if I solve this one for cosine and this one for sine, I would get x over 3 is cosine 2t, and y over 3 is sine 2t. Okay, and then how could I use this identity? Well, what if I squared both sides of this? I can do that if I take this equation. If I square the left, I can also square the right. If I square the left, I'll get x squared over 9 is equal to cosine squared 2t. And for this one, I'll get y squared over 9 if I square the left-hand side, and sine squared 2t. And so we did say that sine squared of a number or angle plus cosine squared of the same number or the same angle is 1. And it's at that point that I think I can use that. All right. So you might look at it like this. So cosine squared 2t plus sine squared 2t is 1. That's the right-hand side of this. If I take this plus this, I'll get 1. But they're linked over to this and this. If this plus this is 1, then this plus this is 1, because they're equal. All right, so then I'll get this. I'll say the path is x squared over 9 plus y squared over 9 equals 1. And we want to recognize this as a circle. I did say that, as a matter of fact, that right there, the path is a circle, radius 3, center at the origin. And you might recognize that from here. If you don't, then we'll get one more thing. We'll multiply both sides of that by 9. And it will say x squared plus y squared is equal to 9. So hopefully then, with this right here, we recognize that 1, that's the standard equation of a circle. The radius is the square root of this number, that's 3. And the center, because that's really x minus 0 squared and y minus 0 squared, the center is 0 and 0. Okay, so that's what I wanted to establish about this. All right. Now, to generalize about this, if we saw parametric equations where x was a number times cosine of something and y is a number times sine of something, if those match, like they're both 2t, and these match, they're both 3, then it will be a circular path, and the radius will be that number. All right, like in this case 3. The 2t right there doesn't happen to determine the radius of the circle or anything about it, because notice, like, no matter what that would be, it's going to cancel out. As long as this is the same as that, I add those and I get 1. All right. Okay. So what one down? All right. Let's look at another one. So here we go. It says, so I want to do something like the one we just did, but a little bit different. Give the equation of the tangent line at the point where t is negative 1/2 for parametric equations x is 6t, y is 1 minus 4t squared. All right. So I think we can do this one like the last one. The path this time, though, is a parabola. Y is 1 minus x squared over 9. That's not too hard to get. It's not hard to eliminate t from these. If you solve this for t, it would be x over 6. And if you put it in there, then that's what you're going to get. All right. It's a parabola whose vertex up here is at 1, has an intercept here at 3, and another one over there at negative 3. So this point for us at t is negative 1/2. Sure enough, if you put negative 1/2 in there for t for both of these, you get negative 3 for x, 0 for y. That's one of the points that would be on this parabola. It's just that according to this, you're at that point at this value of t, or at that time, if you want to think of it as motion. All right. Maybe it'd be weird to think about a negative time, but if I said that x and y are the place and t is the time, if that would give you a model for how to think about this, then that's all I'm saying about it. There's the tangent line. That's what we're looking for. Okay. What's the equation of that tangent line? It's all in the picture. We just have to sort through the math. So let's do this one. I think we can go through the same strategy as there. What's the first thing that we did in that other problem? Find the slope. Okay. So what's the slope of the tangent line? Well, so that was by that formula where we did like y prime over x prime. Okay. So I'll get negative 8t, okay, for dy dt, the derivative of this. All right. And then I'll get 6. And yes, that slope formula is a function of t because it's different at different points. but my point has t to be -1/2. All right. So if I evaluate this at -1/2, I'll get -4 over 6, or sorry, I'll get 4 over 6, but I'll reduce that to 2 over 3. All right, so the slope of that line, it's a positive slope, right? It's 2 over 3. So this line right here is sloped such that it's right 3 and up 2. That's what we're saying about this. Right 3, up 2. Oops. Okay. Rise over run, that's what slope is. This is telling us the slope on the xy plane of that line. All right, so there I got my partial answer. Okay, so my partial answer is y equals mx plus b, because that's an equation of a non-vertical line like this one. And I know that the slope is 2/3. All right, so y is 2/3 x plus b. Okay. So now, of course, I say this is the partial answer because I haven't figured out b. That's 1, so I know it's above the 1. But just from my sketch, I can't tell what it exactly is. Okay. Well, anyway, okay, so I'll have time to figure it out. Let's see. So do I know a point on this line? Yeah, see that point right there? It's obviously on that line, right? We wanted the tangent line at that point. The point, -3 for x, 0 for y, it's on that line in red. It's on the tangent line. So I could put 0 for y, -3 for x, and that known point is enough information to solve for b. So I'll get that b is 2 if I do that. All right? So my answer, equation of the tangent line, y equals 2/3 x plus 2. So it looked like that line would hit slightly above 1. Here's 1 on the y-axis, and the y-intercept, it turns out to be 2. Okay? All right. So let's look at one more thing. All right. So could we maybe do something in reverse where instead of finding the slope at a point, we're finding points that have a certain kind of slope, okay? All right. So it says for this, whatever that looks like. Now, at this point, I'm not worried about what that looks like. It's some kind of a curve, all right? Could we locate the points where the tangent line is either vertical or horizontal? So like vertical, horizontal, okay? So horizontal, well, a horizontal line has a slope of 0, okay? And a vertical line has a slope that's undefined, okay? Now there could be other portions on the curve where the slope's undefined, but vertical means the run is 0 for whatever the rise is, all right? So the rise is not 0, the run is 0, that's vertical. So how about this? Let's start by finding our slope formula. Okay. So in general, the slope is, what was our formula? The derivative of y dy dt over dx dt. So I'll get 2t minus 8. So that's dy dt over 2t. Okay. Now, so it's a fraction. Now we'll find out about this, that it is 0 or horizontal if that expression on the top is 0, but the bottom isn't. Okay? So in other words, horizontal means dy dt is 0, but dx dt is not 0. All right, so if the top part is 0, but the bottom isn't, in other words. And vertical would mean the opposite. Okay? dx dt is 0, but dy dt is not 0. Okay, so we'll think of it like this. Horizontal. Okay, we need 2t minus 8 to be 0, but we need 2t to not be 0. Well, that should be okay. Whatever number makes this 0 is not going to make that one 0. Right? If you just solve this, you'll get 4. Does 4 make this 0? Yes. Does it make that 0? No. So, okay, it's okay. So, horizontal at t equals 4, but the actual point on the curve, that's not the point. That's the time. Like, we're thinking of this as times and places. Like, at that time, you're on that place on this curve. All right? Times and places. So, that wouldn't really be a point. The point I find from this, if t is 4, where am I? X and y, coordinates, and so on. So if I put 16 minus 9, so I'll get 7 for x. And then here, 16 minus 32, so I'll get negative 16 for y. So there's the point on the curve where it's flat or horizontal. And vertical, I need the opposite. I need 2t to be 0, but 2t minus 8 to not be 0. Well, whatever makes this 0 is not going to make that 0. So we should be okay to solve that. In fact, what makes this 0 is t is equal to 0. But let's make sure. If you let t be 0, is this 0? Yes. Is this not 0? Yes. Okay, so that's the number that works. The point, though, the point on the curve, this is not the point. That's not a point. The point is negative 9 and 0. So that's the spot. That's the place on the curve where it's vertical. All right? But, you know, I've been trying to emphasize the difference from the beginning of all this. Like, that's a time and that's a place. This is t and that's x and y. All right? But if that's bothering you a little bit still, or if there's anything about this that might be bothering you, go back and look at that first video on parametric equations. All right? It gives more examples of a lot of the stuff that I've talked about along the way here.